Is it possible to write an equation in slope-intercept form when all you are given is a table? And the answer is yes, it is. As a matter of fact, it's possible to write an equation in slope-intercept form if all you're given is a table that has just two coordinate pairs on it. So this table gives us more information than we need. It gives us 5 coordinate pairs, but we really just need 2 in order to find the slope and the y-intercept. So if we're allowed to pick any 2 coordinate pairs we want, we usually want to pick the 2 that are going to be the easiest to work with. Now, in this case, unfortunately, one of the coordinate pairs that we're given is not the y-intercept. That would be really nice if one of our coordinate pairs had an x value of 0, but it doesn't. So the 2 that we're going to pick are just going to be the 2 lowest. So we're going to use these 2 coordinate pairs right here at the end, and those coordinate pairs are going to be 114 and 220. And we're picking those just because they're the lowest numbers. If we picked any 2 coordinate pairs, we would get the same answer. So what are we trying to do? Well, we're trying to eventually get our equation in slope-intercept form, y equals mx plus b. M can be found by getting the change in y over the change in x. If this was a graph, we would just be counting rise over run, which is how you do change in y over change in x from a graph. On a table, though, we're going to actually do just a little bit of subtraction. You may have seen in science the Greek symbol that means change. Sometimes we abbreviate change in y as delta. Delta y, delta x means the change in y over the change in x. Doesn't matter. All we're doing is seeing what's x changing by, what's y changing by. So let's look at our 2 y coordinates. Our y coordinates that we have here are 14 and 20. So we were at 14 and we went up to 20. So what happened? Going from 14 to 20, what happened? And the answer is we went up by 6. 20 minus 14 is 6. So to get from 14 to 20, we went up 6. So the change in y is a positive 6. All right, now let's look at our x's, 100 to 200. Again, we went up. To get from 100 to 200, you go up. How much did we go up? Well, 200 minus 100 is 100. So to get from 100 to 200, we went up by 100. So if I was going to graph this, I would probably reduce this fraction to 3/50ths and then leave it like that so I could have the rise over run. But I'm not going to graph this. And because this problem is talking about money, I think I'm just going to go ahead and divide 6 divided by 100 and get a decimal right now, which is 0.06. And I'm going to leave this as my m. And the reason is I want to be able to explain my m in terms of money. 0.06 for my m means 6 cents. $0.06 per minute. And $0.06 is 6 cents. So 6 cents per minute. That's what my slope means. Y over X is my unit, and Y was dollars and X was minutes. Dollars per minute. So 6/600ths of a dollar per minute, or 6 cents per minute. That's what my slope means. Cool. Now I got to find the y-intercept. Now there's 2 ways to find the y-intercept in this problem, and I'm going to show you the lengthy way first. I'm going to show you the longer way because it's math, and we always like to show you the long way first, and then I'll show you that there's actually a pretty short way to get it in this problem. So our goal, as you'll recall, was to get the equation in y equals mx plus b, and now we know what m is. M is 0.06. 0.06. So what I'm going to do here is I'm going to find a value for x and y, and I'm going to plug in the x and y to this equation so that I will have a number for y, m, and x. 3 of my variables will be replaced with numbers, and the only variable I won't know will be b. And so I'll be able to solve this equation for b. If I replace the other three variables with numbers, I'll be able to figure out what the fourth variable is. Well, where am I going to find a value of x and y? The table actually gives me 5 of them. The table gives me 5 coordinate pairs. 114 and 220 are two of the coordinate pairs that we use to find slope, but we could use any of the three that we haven't used already also, 326, 432, or 538. Any of those will work for our x and y. Again, if they'll all work, I want to choose the one that's going to be the easiest for me. And so I'm going to choose not only 114 because it's the lowest, but also because multiplying by 100 is pretty easy when we're dealing with decimals. So I'm going to reuse this point 114. Of course, 100 is the x and 14 is the y. So I'll have 14 equals 0.06 times 100 plus b. Okay, so now all of the variables except for b are now numbers, which means I have enough information to figure out what b is. So 0.06 times 100 is really easy. Multiplying a decimal by a multiple of 10 is pretty simple to do without a calculator. You just slide the decimal over a couple of times. 0.06 times 100 is 6. 14 is 6 plus what? 6 plus what is 14? Of course, the answer is 8, but if you didn't see that right away, you can figure it out by subtracting 6 from both sides using that subtraction property of equality. And there's my value of b. So my m is 0.06, my b is 8, so I can write the equation as y equals m x plus b. There's the answer. Done. Now I said I was going to show you the long way, which is plugging in the x and y. Let me show you what the short way is. And to find the short way, we have to go back to the table. Now remember, the y-intercept is 8. Let's go back and look at the table. And this table is really handy because all of the x's are increasing by the same amount. From 100 to 200, we go up by 100. From 200 to 300, we also go up by 100. From 300 to 400, we go up by 100. Look at that, we're going up by 100 every single time. Now, what I want to know for the y-intercept is, what's the value of y when x is 0? If going up by 100 moves me to the right, doesn't it make sense then that subtracting 100 would move me down to the left? 100 minus 100 would put me at 0, wouldn't it? Makes sense. Can I do the same thing with the y's? Well, the y's are also increasing by the same amount. They are always increasing by 6. How about that? So wouldn't it make sense then that subtracting 6 would get me back one space? Going up by 6 moves me to the right, then subtracting 6 would move me to the left, and 14 minus 6 is 8. So the y-intercept is 0, 8. So a perfectly reasonable question to ask might be, do we ever need to plug in that x and y? Do we ever need to do it the long way? Can we always just count backwards from the table? And the answer, unfortunately, is no. Unfortunately, we cannot always count back from the table. Let me give you an example of when you couldn't. Let's say the table looked exactly like it does right now, except instead of the first number being 100, the first number was 110. Well, now it doesn't work anymore because now if I'm at 110 and I count back 100, I'm not at 0, I'm at 10. So I can't count back to the y-intercept. So unfortunately, this doesn't work every time. Sometimes we do have to plug in the x and y and do it the long way, but this is a shortcut we should always look for at first to see, are the x's going up in such a way that if I counted backwards, I could land exactly on 0 to find the y-intercept? Sometimes we can, and it can save us a lot of time. Sometimes we can't, and we have to do it the long way.